So it's on the module, but it's not on your to-do list yet because it's more than 7 days out. But there's a thing called a Thanksgiving challenge. And there are 8 things on this list that you can choose from. And if you do 3 of these things, I will reward you with a homework pass. So if you already have a 0, it will make up for it. If in the future you have a day that you don't want to do it, I will just put the 100 points in and they will sit there and wait until you need them. If you do all of your homework, then it's a bonus because it will add 100 homework points to your overall total, okay? I would love to just give you this and be like, you guys are great people, just go out and do it. And some of you might, but you're a teenager, so let's face it, I have to bribe you, okay? So of these tasks, and if you wanted to do all 8, amazing. But if you want to do at least 3, one is just tell your parents how much you love and appreciate them. And some of you, again, think that you say that and they hear it all the time. But if you sit down and seriously have a conversation with them, I bet it would move mountains. 2, call a grandparent, relative, or friend that you haven't talked to in a while. Call, don't text, call, FaceTime, something like that, where you actually communicate. 3, make a list of goals for yourself, at least 3 short-term and 3 long-term goals. 4, do something nice for a stranger, and I don't mean hold the door open. You should already be doing that, okay? 5, send an email to your favorite teacher, past or present, telling them how much you appreciate them. You do not get extra points if that comes to me. Feel free to send it to somebody else, okay? Make their day. No worries. 6, do something volunteer work over the break. And again, if you already have something scheduled, bonus. You're already doing this stuff. 7, say a sincere prayer of thanks to God for all of your blessings. And 8, write a letter of gratitude like was in that video to someone that's impacted your life. Read that letter to them in person or over the phone.
How do we prove that we did it?
So I am 1, it's kind of honor system. I'm hoping that you won't lie about being a good person. So you are going to, and I'll show you that's what the next thing is. You are going to give me a little bit of a summary of what you did. I did this, and it doesn't have to be like a 5-paragraph essay. I'm not checking your grammar. I don't care, okay? But I chose to do these challenges, and in these challenges, this is my experience, something like that. If it's a personal thing, you don't have to go too deep. If you don't want to share with me, that's okay. I did this. You could be vague. That's fine. And then I used to do this just for free for points, but that's not the world we live in anymore. I had to throw math in order to give you points for something. So we're going to talk about the exponential effect of what you're doing, okay? So this PDF in the first box is where you're going to give me 2 to 3 sentences on the experience, okay? So I volunteered. It was an amazing experience. I worked with whatever, blank. I called my grandparent. They said, I don't like you. Why are you telling me this? I don't care what the experience is. You can give me a little bit of it, okay? And then on the bottom is to talking about the effects of your paying it forward. So if you do 3 of these things, let's say, you would start as your 1 person, and you could be as artistic or basic as this as you want. If you are person 1, if this is you, if you are a dot, okay, on this, and you do 3 things, you have impact 3 people. Hello, right. I've seen some super cute things done, by the way, like little icons, little pictures. If you're artistic, do whatever you want, okay? Then if those 3 people pay it forward to 3 more people each, and you're going to go 5 rounds on this. That's the first part. Then, because we're in exponential, this works perfectly because you're going to talk about the exponential effect of that. So you're going to come up with a little equation that gives you a model of how that 3 times would go forward. Guess what? It's 3 to the x, people. That's your model, right? If you as 1 person complete it, how many people are you affecting? 3. If those people then go another round, it's 9. So can we create an exponential model? Yes, it would be
3 to the x.
Y equals 3 to the x, okay? And then fill out your little T-chart and graph it.
Oh, wow, that's so cool.
All right, so the 212 is log function and manipulation. This is a review. Hopefully we remember the properties of logs when we expand and condense. Okay, that's the good chunk of it. I could probably give you the homework now and you could do all but the last 2 questions or 3 questions because it's then applying it. So in the beginning, we're literally just talking about what happens when we expand or condense. When you have a log of a product, if you expand it out, you add. So if it's log base A of U plus V, or U times V, then it becomes log base A of U plus log base A of V. The quotient property says if you have a quotient, so you're dividing, it becomes subtraction. And the power property says If you raise a log or an exponential to, if you raise the base, no, not even the base. If you raise the log to a power, then that power gets bumped forward on the front of the log. And all of this comes from the rules of exponential functions. So like if you think about if I had two bases that are the same and I multiply them, what do I do with those exponents? I add them. So that's the idea behind the product property. If I had x to the fifth over x to the second, what do I do with those exponents? Subtract them. So that's where the quotient property comes from. And if I had x to the second raised to the third, so I'm raising a power to a power, what do I do with those? I multiply them. So all of these are justified or brought on by those rules, okay? So one part of this lesson is to expand it. You'll get one log, and you're going to expand it using these properties. So if you look at one here, and the instructions say use log properties to expand the expression as much as possible. This is a product, right? But it's also a power. You have two choices here. You can literally distribute that power to both and then expand, or you could bump the power to the front and then expand, but you have to make sure if you bump it to the front when you expand it, goes to every term when you expand it. So the first method, if I just distributed it, would be log base b of x to the second times the square root of z squared. What happens when you square a square root? It cancels out, so this becomes log base b of x squared times z. Then it's multiplication, so when I separate it out, log base b of x squared plus log base b of z. And then I cannot leave a power when I expand, so this bumps to the front. 2 log base b of x plus log base b of z. So it's expanded as it gets. If I had done it the other way, 2 would have been on the front. I would have separated it out, log base b of x plus log base b of the square root of z. And then this would get distributed to both, 2 log base b of x plus 2 log base b square root z. And that square root is a power. It is a 1/2. God bless you. And then the 1/2 would get bumped forward and cancel out the 2. So you'd get the same answer. Obviously, the first way I think is easier this time.
Which one's like easier, like to leave less room for error?
So I would see if I distribute it, does it cancel something out? If it doesn't, then it doesn't matter. Okay. But in this case, where it canceled out your square root, I would go that route. Okay. Yep. All right, so, and also forgetting to distribute. So I would probably, like at the end, like once you bump it to the front, people tend to forget to distribute back in. So I would probably go first method. All right, so this one says log base 5 of 25 over y to the third. So I'm going to distribute the 3 to both, the exponent on the numerator and the denominator. So then if it's division, it becomes what? Subtraction. This would be log base 5 of 25 to the third minus log base 5 of y. Now anything with numeric bases and the term next to it, I would check to see if I could simplify. I can't do anything with log base 5 of y, but log base 5 of 25, there's 2 ways you could go from here. 1, bump the 3 to the front. And it'd be 3 log base 5 of 25. What's log base 5 of 25? 2. So this becomes 3 times 2 minus log base 5 of y. 6 minus log base 5 of y. So you have to distribute it, or you have to simplify it if you can.
Where does the y cube go?
Oh, no, that 3 is still there. It was here, and then it would get bumped to the front. So it'd be 3 here. 6 minus 3, thank you. That 3 should have still been here on the y. All right, and then the last one. So what is the exponent if this whole thing is being square rooted? 1/2. So this is really log base 3 of x to the 5th, y to the 7th, raised to the 1/2. That square root is the same thing as raising it to the 1/2, right? So this is one of those cases where I would check. If I distribute this, does it simplify any of those exponents? No, so it might be better to push it to the front. X to the 5th plus log base 3y to the 7th. And then I got to bump each of these individual powers to the front. So 1/2 5 log base 3 of x plus 7 log base 3 of y. And actually, if this was multiple choice, so like I would take it if you distributed. So it'd be 5/2 log base 3x plus 7/2 log base. I would take that answer if it's open-ended or this answer. Multiple choice would most likely have the 1/2 at the front. So if you did this, you would need to know that they took the 1/2 out. So again, open-ended answers, both are going to be fine. Multiple choice, they'll take that 1/2 out.
Wait, so both answers are right?
Correct. Yep.
And what highlighter color is that?
Brown.
All right, same set of instructions. So look at 4. You've got a mix of products, exponents, and a quotient, right? So break this apart. The first thing I can do is log base 9 of 81. Now this is a product, right? So when I separate it out, what happens? It's good. So it's plus log base 9 of a to the 4th. And that is over both of these things. So even though that's a product in the bottom, they're both in the bottom, which means they both get a minus. So this would be minus log base 9 of b squared minus log base 9 of c to the 3rd. So any term in the numerator stays positive when you separate it out. Any term in the denominator becomes negative when you separate it out. And then I'm going to bump these exponents and the ones with the numbers. I'm going to check, can I simplify that? What's log base 9 of 81? 2 plus 4 log base 9 of a plus, minus log, minus 2 log base 9 of b minus 3 log base 9 of c. Still good? All right, LNs are involved now, so we're going to pay attention to things like ln of e, right? Because L of an e would be the same thing, what would be like a log with the same base. So when I separate this out, I get ln of e to the 3rd minus ln of 8. What is ln of e to the 3rd? 3. That cancels, giving you your exponent. Same thing would have happened if I bumped it forward. It would have canceled, giving me 1, and 3 times 1 would have been 3. And then I can't simplify ln of 8 without a calculator, so I leave it like that. All right, now I've got log, but instead of having a product or a quotient, I have a sum or difference, right? So I can't separate this as it is. But is there something we can do inside those parentheses? Factor out what? This becomes log 10 times x minus 5. Now I've got a product, right? You don't need those parentheses as long as you know that the log is you're taking the log of the whole thing. So when I get a product, I get log base 10 plus log base 10 of 10 plus log of x minus 5. Can I simplify log 10? It's 1, right? Because that base is 10. Question so far? Yeah.
The reason the LNE went out is because LNE is just 1.
Right, because log base e of e. It's not that it's just 1, it's that it's whatever the exponent is. So if it's by itself, then it's 1. But if it was log base e of e to the 3rd, it's 3. Yep. All right, now we're going the other way. Now you're condensing. So this is exactly the same slide as before, but flip-flopped. So you're going to start with the sum, and it's going to end up as a product. And I'm going to start with a difference, and it's going to end up as a quotient. And I'm going to start with a number on the front, and it's going to end up as a power. How do I know the difference between this and the last one? Because it could say condense or expand. If it literally has 2 logs in it, obviously we know we're going to condense. And if there's a number on the front, then we know it's got to get bumped back. So they look like this. The directions say write it as a single log, so we know that's the goal. So what do I do with A? What's something I could do first? Good. So you're saying bump this back. Yeah, bump these back. So this would be log 2a to the 1/2 plus log 2b to the 3rd. The addition makes this multiplication. So this is log 2. What's a 1/2 on an exponent? Square root a times b to the 3rd. And you don't even need the parentheses as long as you make sure that b to the 3rd is not underneath the square root. All right, go to B. So I've got a power here. This becomes y squared. And then I've got a subtraction, which becomes division. Log 6x over y squared. C. I'm going to take the 2 and the 5. I'm going to bump them back. And then subtraction, so division. 3 squared over x to the 5th. Anytime I'm just numeric, I'm going to check to see, can I simplify it? What is 3 squared? Oh my gosh. All right, now look at D. You have a mix of negatives and positives. Order does not matter here. If I move these around, the negative 6 with the 2 ln y and the positive 6 with the 5 ln x. So anything that is positive becomes your numerator and anything that's negative goes to the denominator. So I'm going to bump these exponents back. And then ln out front. X minus 2 is positive. It's going in the numerator. Y squared is negative. It goes to the denominator. X to the 5th is positive, so it goes in the numerator. Because it's not negative. So what happens if you switch these around? Does that matter? As long as that plus stays on the 5 and the negative stays on the 2, right? Addition and subtraction are associative. You can literally move them around, group them in different orders, commutative and associative, because you can move them around. So if it's a plus, it goes in the top. If it's a minus, it goes to the bottom. So honestly, most of that is Algebra 2 stuff. I know there's a couple things in there that we didn't do in Algebra 2, but the properties were the same. This is where IUP just takes it to the next level. Now use those expanding and condensing to talk about what happens to your graphs. So compare the graph of just log of x to the graph of log 100x. What does the 100 inside the parentheses do? It's what kind of compression? Horizontal compression by 1 over 100, right? So this would take my log and it would squeeze it in as though the walls were caving in. So that is the original transformation. But if it then asks you to expand and then talk about the transformation, if I expand this, this would be log of 100 plus log of x. What is log of 100? 2 plus log of x. Now what's my transformation? Vertical, not stretch, shift up to. So a graph of a log with a horizontal compression of 1 over 100 is the same as a graph of a log that is shift up vertically by 2. So the homework's going to say expand it and then describe the transformations and do the domain and range. So A on this one, this would be log base 3 of 9 plus log base 3 of x. And log base 3 of 9 is 2. So what's my transformation? Vertical shift up 2. If I take a log and I shift it up 2, does it change my domain? Nope. Does it change my range? Nope. My range is all numbers for all the logs, right?
Because it's all numbers.
It's shifting it up, but it's still going, yeah. And then your transformations we already described. Go to B, what are you gonna do there? What do you have to do first? So division is if there's two logs. If it said log of 16 minus log of 16x. First gotta take out the 16. So if I take out the 16, I end up with 1 minus x. Now it's a product. So this becomes log base 4 of 16 plus log base 4 of 1 minus x. And log base 4 of 16 is 2. So what's the plus 2 at the front do? Up 2. What's the happening on the inside of my parentheses? The negative on the x does what? Well, the negative on the x over the y. Then normally that's a positive 1 and we would go to the left, but because there's a negative here, it changes the direction, which means right 1. If it's a negative on the x, it flips the direction. Set that equal to 0, right? Set that equal to 0, find your asymptote, it's at 1. Yeah, so it shifted up. My domain is now what? It shifted it to the right? It shifted my vertical asymptote went to 1. So what's my domain? Oh, wait, I didn't flip it. Sorry. That would be if it wasn't negative. This is if it's negative. That's the end result. Now what's your domain? Negative infinity 2. 1. What's your range? Never changes. And the last one, what do? Bump the exponent to the front. 4 log base 2 of x. What's the 4 do? Vertical stretch. Factor of 4.
Can you see the vertical stretch when you graph it?
Not really. It just looks like this. It's taller.
Okay.
Yeah, that's all. Does it affect your domain? Nope. And does it affect your range? Never.
When we're graphing, would you want it to show the vertical stretch or just show
It really doesn't matter. Because the end goal here is to describe it, you could use the words to describe it as long as you know it doesn't affect your domain and your range. Yeah, so the graphs here, I mean, you literally, if you could do it without graphing it, which I can't, I have to see it. But if you could do it without graphing it, then you can describe it without it. The graph is simply to give you that visual of it.
Wait, can you really